Gravity. So in this practice problem here, number 13 of practice 1, we're looking to find the acceleration of gravity on two surfaces. One is on Mars and the other one is on Venus. If we remember the equation for gravity, the equation to find the acceleration due to the gravity, or little g, that is just equal to gm over r squared. That's all it is. It's the gravitational constant, the mass of whatever surface of, wherever you're at or whatever you're kind of around, and then the distance from the center of that object, typically for our planets we're talking about spheres, so we go from the center out, to wherever you are. That's what your local gravity is at that point, and I guess it's a vector because it's a field at that position. So when we do this for Mars and Venus, we're just using this equation, but on each of them we're going to have to change which planet we're at, and so a question mark there, and what is the orbital radius of the planet. So for Mars, for part A, it's the red planet going from the center out. That is our little radius here, and we need the mass of Mars. For Venus, which is kind of like a disgusting acid color, so we'll go with this. We've only been on Venus a few times, not with people, and every time we're there, our rovers kind of melt. Not really melt, but they kind of corrode within the first hour, and we can't get anything back from them. But here's Venus, okay? And that's it. We just need to make sure we have the correct radius of Venus and the correct radius of Mars and the mass of them. So to do this, on the surface of Mars, we've got big G, which is 6.67 times 10 to the negative 11th. If we look at our solar system best friend sheet, we can get the mass of Mars. The mass of Mars is 6.42 times 10 to the 23rd. And then we just need to get the radius of Mars. So the radius of Mars is 3.4 times 10 to the 6 meters. And don't forget to square that. Doing the same thing for Venus. G equals big G, 6.67 times 10 to the negative 11th for gravitational constant. Our mass of Venus is 6.05, no, mass of Venus, 4.87 times 10 to the 24. So it's actually more massive than Mars. And we divide that by the radius of Venus, and the radius of Venus is 6.05 times 10 to the 6th. So it's actually got about twice the radius of Mars. People, for some reason, think that Mars is pretty big. Venus is actually closer to an Earth size than Mars is. Remember, Earth's mass is only 5.97 times 10 to the 24, with a radius of about 6.38 times 10 to the 20, or times 10 to the 6th. So Venus and Earth are actually pretty similar in size. It's just that Venus underwent a greenhouse effect and it is destroyed. But yeah, and that's it. We just plug in these numbers and we kind of get our answer. Oop, guess what I missed? Squared. Can't forget that. That's a huge thing. But yeah, just make sure you plug in those and you'll get values for Mars and you'll get a value for Venus, and that's it. We're done here. I'll leave the calculator to you. I'm sure you can do it. But with that, this problem is finished. Take it easy.